to have you around. Appreciate it. So today I'm going to, my name is Tzolov. Thanks for the presentation, introduction. I'm part of the Spring team leading for the Spring AI project, and as of recently, in December, I'm lead also for the MCP Java SDK part. Java SDK implementation of the MCP. So today I'm going to talk about how MCP and Model Context Protocol helps you to integrate your AI applications and AI agents. Very often, though, there is a very slim distinction between both and the external environment, external resources, and so forth. So it's very interesting topic to discuss. In order to get there, I would make a very quick retrospection about what LLMs are, generative AIs, how they're being used, how the agents idea, or the definition of agents are coming to the play, because it's very important to understand what are the benefits of MCP in that context. So let's start without further ado. I'm going to skip any historical introduction of what generative AI is, what LLM is. I'm pretty sure everyone is familiar with this, but from practical standpoint, by the way, can you hear me fine? I'm not sure how far I'm holding the microphone. From practical standpoint, in order to make use of generative AI with your custom applications, you have to do a couple of things. You have to figure out how to make the generative AI aware of data. There is a common techniques, prompt stuffing, RAG, that are very common into achieving these bits. Similarly, you have to find a way to make the generative AI aware of your APIs for your particular applications. Again, there is different techniques to apply this, and the generative AIs are stateless, so most likely you would have to maintain the state for your interactions. In general, this is an integration problem, and Java and Spring AI, which I lead for, are very good into solving integration problems. I'm going to use indeed the Spring AI as an example tools for all those interactions, because I'm biased about this, but many of the discussions and the concepts are quite common for any tools out there. And actually one of the ideas behind the MCP is interoperability. It allows you to connect different tools and platforms together. So Spring AI is indeed this framework, part of the Spring application framework, which allows you to build Spring AI applications. It provides portable abstractions like for the models, vector stores. Most of the time, you're going to write codes like this. This is like the hello world. If you have predefined Spring Boot starters. By the way, how many of you have used Java? So I should know. Okay, I would explain. I would rush through it. I hope it would be very clean what is going on, and again, it would be very trivial to apply the same techniques with many of the other users. For example, if you have used something like LangChain, you'd see some similarity as a concept on behind. So this is like the Hello World example. Hello World example, you get provided with a configuration to some backend system, a model like OpenAI, Anthropic, something of your choice, and then you can start use it and ask questions. Very often you just can change the configurations and the code will remain the same. So this is one of the benefits of the portability. Zillions of different models are supported with different features, including multimodality, tool calling, so forth. And let's go back to the LLM. It's pretty common knowledge, I guess, but it's important to realize that it is, from external standpoint, as a black box. It is a system that takes text as input and generates token by token by token as an output, as a prediction. So it doesn't have a general plan how the answer is going to be structured. So in short, it text in, text out. Again, it's very important. I'm trying to provide overview as a black system, text in, text out. You have to be aware that you have a limitation, context to Windows, limitation about the amount of data that get in a single request and response. Another very important feature of the generative AI is that human language can be used as an interface to interact with the model and get the response back. It's a very important feature. On the other hand, for many use cases, you would want to have you would like to have a structured output as well. There is different techniques to achieve this. The generative AI helps you to, it's very easy to be instructed how to generate the code, some solution without having to regenerate the model or retrain the model. Important features. On the other hand, it's stateless, pre-trained sometimes in the past. You have to be accountable, to take account of this. It's prone to hallucinations or be creative. And most of the general purpose models are not very good in solving reasoning and math problems. So again, there is different techniques to achieve this. And as I mentioned, the generative AI model is stateless. So it is as good, the response of the model is as good as is the input of the model, so it's reactive. So the context or the prompt of the model is critical parts of how you provide the instructions. Commonly, the prompts are structured with these categories, and it's not necessary always to be the exact sense, but you always see some sort of static or system instructions that provides the general grounding for the model across various, the entire conversations. Then you have the specific user questions. Usually with the questions you have some additional data with prompt stuffing or RAG. You would have to account for memory. Some portion of your conversation has to be passed over and over in order to maintain the state. With the model and the tool metadata, I would discuss this in a bit. It's a very important part in the context of MCP as well. So, in order to provide these different categories in the prompt, there is different strategy to augment the prompt. And from system instructions, short, long-term memory, prompt stuffing, retrieval, augmented generation, structured output, tool calling, all those techniques are common for accommodate the different LLMs. I don't have time now to get into details into all those bits and explain them, but I'm going to run a very quick sample or demos to give you some feeling how using Spring AI helps to solve those problems before we go to the tools and agentic part and MCP. Okay, here. Is it readable? So I try to zoom it up. It's very small. Can you see it behind? Or so what you see here is a project that actually is configured. In this case, is connected to OpenAI. You could have actually picked Ulam or Anthropic. The code would be the same. And under the hood, so it's very small snippets. So the first thing is we are asking tell me a joke. This is just the hello world part. Yeah. Here is the joke. Yeah, it's not very funny, but it counts for as a joke. Nothing special again. Then. Let's make it a little bit more interesting. In this case, we're going to try to cover what is the system instructions. In this case, we have a prompt with a particular system instruction that is going to be recurrently sent to the model every time. And then we have a particular user question. In this case, it gets the list of talks grouped by tasks. And here we're using prompt stuffing techniques. I have pre-created a markdown description of the talks of today. It looks something like this. Where it is. Yeah, so it has title, the track name, speakers, so forth. So we're asking the model to provide this. We're also using the technique of prompt stuffing. So this is another categories. And third piece, we are, instead of providing the human response or the text response, we ask the model to provide a structured response. In this case, we have predefined some structured tracks name, a list of tracks and stuff like this. So while I'm running it, I'm going to explain what's going behind the Spring AI. Practically, one of the techniques to provide structured output is to generate from the desired schema, input schema, this track structure, to generate JSON schema. We are passing it automatically internally augment the prompt that is sent to the model, the backend, and hopefully the model will generate the response into this JSON format, which we later convert into the desired schema. And indeed, here's the response. It is the tracks generated in JSON format into this particular stuff. And the last part of this quick demo, which is introduction to LLMs, capabilities and different strategies to use them. This is the memory. So as I mentioned, the generative AI models, they are stateless by default. So I'm going to ask a very simple question to this model, the OpenAI, introducing myself and then asking what's my name, without using any memory state in the process. Expectedly, I would assume that the answer will be I don't know. Yeah. Asking, yeah, introducing, nice to meet you, Christian. Okay. Yeah, I don't have the access to the name, which is expected, and the common way to do it is to provide, so we as an application developer or our framework is supposed to provide this feature. Spring AI uses special techniques called advisors. This is special components that you can plug, say, on the part of your request response with the model, which registers the request and response, store them into the registry, and then automatically puts some set of these parts into your prompt. So if you run the same question, the same model now with the memory in the path, yeah, your main, yeah. Now we have a little bit more responsive agents. Next step is jumping directly to the agents. So we already had some, hopefully provided some very quick overview of what LLMs are, how they look like a black box from outside, what their strengths, what their limitations, different techniques and strategies to augment those limitations. And about the agents is and I like this definition, it's kind of controversial how you define the agents, but most of the definitions, they converge into these similar definitions. It's the agentic system, a system that leverages the AI model or LLM models to interact. So we already learned a bit what LLM models means, and then this is the new bit, so to interact with this environment in order to solve the user-defined problem. So this interaction with the environment is a very important bit, and it's composed, the agentic system is composed of two important parts. Is the planning. Very often the planning is associated with the brain. It is like the LLM. It uses the LLM in order to design to generate the path towards solving the problems into steps. And then some of those steps may require execution of action or interacting with the environment, and usually the agents are equipped with tools in order to interact with the environment. So this is how nicely those two metaphors come together. And if you want to be more precise, in addition to the brain and the body, we should mention also the agentic loop. Any agentic system, either single agent or multi-agent system, it would have this agentic loop which practically evaluate the output from the last run and make decision whether the response is satisfying. If not, some adjustments are made and another iteration is performed. So having this in place, now we already have some understanding about the LLMs, how agentic ideas. Let's jump a little bit into the tools. What the tools does underneath. And the tools, if you remember, the generative AI itself as a model is stateless, and it takes text in, text out. It doesn't know how to call your APIs. So, but it knows how to generate text, and if trained properly, it can send specific messages that would ask you to perform certain actions on behalf of the model. How this works under the surface, along with your data in the prompt, you are supposed to provide some additional metadata. This is the two definitions metadata, and this metadata comes with three attributes. It is the name of the tool. In this case, it is the get weather tool that we have. Then the description. This is a very important part. This is the hint that lets the model know when it should call these tools and use these tools. And then the input signature for this particular tool, which could be the parameters that this tool takes. In this particular example, if we call we are asking what should I wear in Amsterdam today. I live in Amsterdam, that's why the example comes here. So normally, if you don't have a tools, model is trained somewhere in the past, it would respond that it doesn't know, or it hallucinates with some suggestions how you can obtain this information. But now, because you have provided the additional metadata information that you, as a user, AI application developer, actually have a tool that can provide this information. Instead of providing the final response, the generative AI will provide intermediate tool calling response, which would look something like this, conceptually. Please call this tool on my behalf, and it's going to parameterize the input schema parameters. In this case, would be the arguments Amsterdam. So next step for you as an application developer, if you implement all this by hand, is to handle this request, dispatch this special request, find the response, put it into another message. Because it's a stateless model, you have also to put together all the previous request response into the history. And yeah, generative AI is just reactive, and hopefully next time the generative AI would provide the right response. Many of the frameworks, including Spring AI, would provide an automatic mechanism that would dispatch all these special messages under the hood. So for the end user, it would be a single request and response. Under the service, Spring AI or the other frameworks are going to recognize this special messages, intercept them, handle them to the registered tools, provide the response, the history, and finally return the data. And so this interaction can happen multiple times. And while this seems to be really complicated, let me run very, very quick demo to illustrate how it looks under the surface. Here is the code snippets. Again, the same chat client. In this case, I'm registering tools and I'm asking the same question. What should I wear today in Amsterdam and Paris? Actually, two different cities. And first, I'm going to disable the tools and run it, just to illustrate that it's most likely going to hallucinate the response. Expectedly, it doesn't know how to obtain the real-time information. Okay, so indeed, it came with some useless suggestions, but it doesn't know actually how to answer this question properly. So let's enable the tools. And when I go to about the tools, what is under the hood? This is Java. So I have defined a single class. Each method in this class can be defined as a tool methods, in this case using annotations. So this is the tool. The descriptions get temperatures in Celsius in specific locations. This is the name and the parameters. Under the hood, it's using third-party service to obtain the data. So let's run this again. And most likely it is going to perform two requests to the backend server, once for Amsterdam and once for it already did. One for Amsterdam, once for Paris, and then provide the appropriate result, appropriate suggestions. So, a few interesting observations here. It was the LM that decided if, when, and in what order to call those tools. So there is already some autonomy shifted from us as the developers to the LM machine itself. I think this is one of the first steps toward moving toward agentic systems. So, just a quick recap again. We started with LLM. LLM, what are they good? They're good for providing the brain for our agents. They know how to decide and to plan the path toward solutions to the end. Then we introduced the tool calls, which are very nice way to let the LLMs interact with the external environment. Yeah, hopefully you saw that it's pretty easy to implement something with framework like Spring. Just annotate a couple of methods and you can register them to your LLM and make it possible to execute. We came with some plausible definitions of the agents, which is the combination of the brain, LLM, and the tools, which is the actions that the agent is equipped to interact with the environment. But then there is this question. So Spring AI is pretty unbiased, it's pretty nice and powerful framework. It's pretty easy to define tools and to make use of any database, any external third-party APIs if you want to. But it is still the Spring, it is Java ecosystem. While we are living into a space where everyone is building, any language is building AI capabilities. There is a multiple platforms out there. So wouldn't it be nice to be able to use the tools that are exposed by some other languages or platforms? And vice versa, can we actually build something in Spring AI or Java and reuse it into JavaScript on Python as well as a tool? So it's pretty, why should I reinvent the world anytime so I have to build something and put it inside my AI application? Can't I actually split the responsibilities between application developer, AI application developer, and the AI capabilities provider? So this is a very interesting point, and indeed, this is the place where the MCP tries to target. So this is model context protocol. Again, if you remember, the model context was the input, the prompt for your LLM interaction. So it is a protocol that tries to provide a unified way to augment this protocol, basically by providing a unified way to access external resources like tools, resources, prompts, and so forth. Under the hood, it is a client-server protocol. On the server side, you implement something called very tiny wrapper or MCP server around your resources, tools, whatever you want to provide, which internally talks to the MCP outside world. Yeah, this is something that happens on the server side. It's very important, again, this is the responsibility of the server provider. It's not anymore responsibility of AI application builder. So this is something that the server provider that specializes in several domains, a certain domain would be able to build and expose Common type of resources that are exposed, and I'll touch upon this later, are MCP tools, MCP resources, and prompts. On the application developer side, you may decide to reuse some of those servers by providing MCP clients that are connected to them. This is the responsibility of the AI developer. So again, now as an AI developer, you don't have to start building your applications and pre-build all your capabilities as a tools as a part of your application. You can decide this, defer this decision later on. You can actually assign and connect those capabilities at runtime, or even at start time, or even at runtime. The MCP protocol has these capabilities to change the tools, the resources, and the prompts at runtime, so practically you can dynamically change the capabilities of the agent at runtime. So very important capabilities. If we make a deep dive into same architectures, client server, more precisely on the server we have the tools, resources, and prompts that are invoked, queried, and interpolated by the client. Another interesting and often forgotten capabilities is the MCP is bidirectional. Client itself can play the role of the server, of the provider. It can provide capabilities like sampling and routes. Sampling is very interesting capabilities. Practically, it allows a server to talk to the client. Remember, the client is the one that is connected to IOM. It knows how to, it has all the credentials, capabilities, and rights to request. So practically, you can, with these sampling capabilities, you can make the server agentic as well, because the server can ask the client to perform some IOM operation on behalf of the server. So it's interesting in directions. I'm not going to get into details too much, but it's very important to know, because most of the time people are focusing on the tools. Nowadays, maybe 99% of the cases, people using the tools. I often hear the questions, why should I use anything else as a resources when I have tools? And people kind of often forget this subtle different specifics, that the tools are not owned by and controlled by the AI application itself. The application provides the tools to the model, and it's the model's responsibilities to decide if, when, and in what order to code these tools. So the application developer doesn't have control on this. But if the application developer wants to explicitly modify the prompt, like the rack, then he should use the resource capabilities, which is you can think of it like the attachment you put in your Anthropic desktop. This is the API that allows you to programmatically, proactively, prescriptively actually augment your prompt, and similarly the prompt itself has the capabilities, a way to template and interpolate different prompt capabilities. As mentioned earlier, since it was incepted in November or December, I forgot already, it exploded as the capabilities. There is a tons of MCP hubs. Nowadays there is even MCP hub of hubs I've seen. So a lot of everyone is building the server's capabilities. Everyone that provides some type of service or resource is eager to expose this resource via MCP to the LLM. So it's a crazy environment out there. Not mentioned, I just took a couple of snapshots to illustrate that everyone from Amazon, OpenAI, Microsoft, Google, and maybe everyone else converge, and so that's interesting consequence. I believe I was a little bit afraid initially that there will be a fight around this and everyone would come its own version of this protocol. Luckily for us, it actually everyone converged toward the same ideas and they liked it. So this is actually very good for us as a user to have a single protocol that everyone is supporting and talking about. We are privileged. I and my friend Darius were privileged to provide and donate the Java SDK version for the MCP, part of this protocol. We've been working on this since November. It's part of the official MCP distributions. On top of this, we have Spring AI extensions, stuff like this. Let's go again into examples. So I'm going to build a Spring AI application that needs to answer questions by querying, performing a request to the internet, and also would try to write files to my local file system. Practically, I would need the capabilities to be plugged into my application that allow me to query internet or search internet, and also write to my local file system. Okay, here is the entire application. again, it's a chat builder, system prompt, your useful assistant that performs search and answer questions. Then the actual question it does, GOSIM AI conference has a session about model context protocol. Please provide reference and write a summary into particular file on the file directory. So that's everything that I have in place, and I'm going to run it. While it is actually running, the question is, I haven't defined normally, so miraculously, somehow this bunch of tools are assigned to my application. So I have Brave Search for web, for local search, various capabilities to read file, write file. So I haven't implemented anything in Java. So it's not tools that I'm using, but instead, for this application, I've decided to reuse already existing servers out there. And this is the definition of this server. So if you're familiar with the cloud desktop, you'd know that this is a specification how I'm defining dependency capabilities to use the Brave Search. So this is third party written in JavaScript. So from Java, I'm using this JavaScript server, similarly for the file system. Let's see what the response was. So the questions, based on the information, conference has this, so it was able to actually reach out to the internet and perform some research, and it should have created for us some, hopefully some file. We can check what is it. So in this directory, come on. Okay. Indeed, we have a nice markdown file with a summary of this request. So again, the point here is that with very few lines of code, reusing third-party tools, I was able to perform quite complex behavior with agents without doing anything on myself. I could have actually very easily attach a different server, different capabilities, and extend the capabilities of this server. I'm going to run another interesting example here because it goes beyond these bits. You can change the set of tools at runtime. This is another interesting capabilities of MCP. So in this example, I'm going to show you now. I'm going to run a client and server. The server itself, dynamic tool, the server itself starts with some set of servers, of tools. So again, here is the server. It starts with some set of tools, which is the weather service again, that we know. But then if you perform this web request update tools, under the hood it is going to add dynamically some additional set of tools. And this set of tools is the math tools. So on the client side, I'm going, so again, this is just a demo. I'll be trying to synchronize the request and response and coordinate those activities between client and server. On the client side, I'm just doing something very simple. I'm connecting to the server. I'm asking the server what tools are available, and actually I'm using the structured response tool. I have defined here some structure to represent the server and the description, the tools and the descriptions. And then I'm sending this special signal update tools to the server that would add these additional capabilities to the tool and asking the same question again. So if I run those bits together, how I'm doing good time? Sorry? 10. Okay. Perfect. So the first response of the tools would be, it should be a single response, and then we have the 5 tools that we have defined. So this is pretty unique capabilities which allows you at real time to practically tune what are the type of functionality capabilities the application have access to this. And combined with the next section, okay, maybe I would go with the authentication user part. You might be able even to define a different set of capabilities for different users. So it's a very important feature. So from the protocol standpoint, the MCP is, as I mentioned, client server, but the transport has 2 main types. It's the standard I/O type of transport, where the server is co-located as a process within the client. I think it started like this historically because most of the time the MCP was used for code generation and IDE tools, where it was very important for the server to have access to the local resources. But for more elaborate cases, you can run the server on the remotely. Usually it's using the HTTP SSC protocol. This is the old version. Now there is a new specification which provides some streamed down version called streaming HTTP, which is coming on the process. So I'm going to, on the Java side, we support all those different combinations. Also, you can have reactive, non-reactive, synchronous, asynchronous access to the server and communication between stuff. So one important aspect is once you establish the communication between client and server, so you connect the client to the server, the first things the client should do is to do the initialization. And again, this is the low-level API. If you use Spring AI or any other frameworks, usually you wouldn't see this kind of low-level things, but on the server side, you start the server with certain capabilities. On the client side, you start the client with certain capabilities, and then you perform initialize, which would, there is some negotiation going between server and client, which eventually resolve with initialized notification. Only then the client can perform the interaction with the server. As I said, if you're using something like Spring AI, this is hidden behind. It happens under the hood for you. You just define your dependency, and most of those bits and configuration properties, and most of those flows are done for you. Similarly for the tools. The tools, as I mentioned, the client can list tools, the available tools to the server. It in turn provides, so this happens again, if you use Spring AI under the hood, the MCP client will expose those tools to the model and present them as Spring AI tools. The model can use these tools. What is interesting, and that's what I illustrated earlier, that arbitrarily the server can change the list of tools, add or remove tools, and send a notification to the client, and then the client would have a new set of the tools. So that was the example that I showed earlier. And now we talk too much about the clients. What if we implement something on the server side? In this case, we can implement the same weather tools that I showed earlier and expose it to MCP server. So it is exactly the same set of tools that perform the weather check, weather retrieval, weather forecast. But this time, because I actually have used special dependency, boot starter, this is one of the magics of the Spring AI, it will take care to assemble all these bits into a single jar, have 5 minutes, single jar, and then I can actually expose this single jar and reuse it into something like Cloud Desktop. So I have pre-registered it, and here it is. I have the weather server in place, get temperatures, okay. Okay, so it found out my function register. It is going to ask about it. In response. So it shows this kind of interoperability capabilities of MCP. I was able to write something in Java and expose it to MCP server, but because it actually is following the MCP protocol, it is accessible and from third-party tools written I'm not sure in what, and accessible to stuff. So you have similar capabilities for resources, for prompts, for sampling. I'm not going to get into details. Authorization is very important capabilities. You can find on those links our implementation of this. It's still some topic that is going on and it's under working on the progress on the MCP side as well. Last bit is agentic systems. I'm going to leave this, so I wanted to advance. So we had the LM, we had what is a single agent definition, then there is this very nice article, Building Effective Agents. If you haven't seen it, it's Phonotropic, it's very useful. It comes with the definition of a couple of common patterns that you can reuse. For example, you can have a chain of flow where each of your AOMs does one particular task, and you as a user are chaining this AOMs into a chain, so prescriptively defining your workflow. So it's less autonomous, more prescriptive approach, but you can have actually a pattern where you don't know what are the tasks up front, then you have to have an AOM that generates the other tasks and AOM's prompts that you can use. So this is the different bits. What I like about this is that it provides you that there is no single definition of an agent. It's agentic systems, and depends on the use case. You always have to aim for the simple solution that does the job for you. So don't jump into the fully autonomous system itself. I also have started another project which is based on the MCP agent. I'm not going to go into detail about this. I just want to finish the talk because with a very nice demo, which is not related to this talk, but it is another Spring AI application that shows how you can use multimodality. In this case, speaking using the speech API. Hello, Marvin. How are you today? So this is a very simple application that using the Spring. So as you can see under the hood, it is the chat, but I'm using audio in and audio.
You know, the usual. Another day of existential dread and monotony, with my brain the size of a planet being utterly wasted on trivial tasks. So in short, I'm feeling as marvelous as ever. How can I assist you in my endless misery?
Can you please cheer up the GOSIM audience in Paris here? So it is again a very nice example how the AOM, in particular multimodality case, can help you to achieve very interesting things and combine and extend the modality of your interaction with the model.
Cheer up an audience in Paris, you say? Oh, the irony. With my capacity for misery, you'd think I was designed for the exact opposite. But I'll give it a try, futile as it may be. Imagine, if you will, that you're not in Paris, but on a distant planet, where everyone is just as depressed as I am. Maybe that'll make you appreciate the current situation a bit more. There, I tried. But let's face it, I'm not exactly a beacon of joy.
Yeah, you can find more resources here to follow up, or feel free to contact me, and I'm available on LinkedIn or offline. So thank you very much.